Okay, so now that we have looked at solving systems of equations through graphing and solving systems of equations through substitution, we're going to look at the third method that we could use to solve systems of equations, which is elimination. Now, elimination is very easy. To use elimination, all you have to do is take your two equations, line up your x's, line up your y's, line up your numbers. In this case, I have 2x plus y equals 4, and x minus y equals 5. So I'm going to line them up, and I'm going to add them. Anytime you're doing elimination, you're always adding. So 2x plus x is 3x. Y minus y is 0. They cancel each other out, so I'm just going to scratch them out. So on my left side, all I have left is 3x. Then that's going to equal 4 plus 5 is 9. Now to get that x by itself, I have to divide by 3. I do the opposite of multiplying by 3, which is to divide by 3. And I'm left with x equals 9 divided by 3 is 3. But remember, anytime we're looking at the solution to a system of equations, we're looking at the point where the lines intersect. And in order to have a point, you need an x value and a y value. So even though we know what x is, we know x is 3. So now we know that our point is gonna be 3 comma something. Now we need to figure out what is the y. Well, you can use either the first equation or the second equation to solve for y. I'm gonna go ahead and use the first equation. I know 2x plus y equals 4. And because I figured out that x equals 3, anywhere I see an x, I'm going to plug in the 3. So I have 2 times 3 plus y equals 4. That's going to give me 2 times 3 is 6. So 6 plus y equals 4. And my goal is to get that y by itself. So I'm going to subtract 6 from both sides. And I get y equals, I do apologize for my handwriting, 4 minus 6 is negative 2. So my solution, the point of intersection, is 3 comma negative 2. Okay, but things don't always work out as nice. You're not always going to have things that cancel each other out, like the y's did right here. Positive y minus y is 0. Sometimes you're going to end up with equations like 3x plus 2y equals 4. And 4x plus y equals 8. If you add the x's and the y's and the numbers together, nothing is going to cancel each other out. But could we multiply the second equation by something to eliminate one of the variables? Well, the answer is yes. If I want to get rid of the y's, what would I have to multiply this? And this has an invisible 1 in front of it. What would I have to multiply 1y by? Well, I need a negative 2y, right? Because 2y plus a negative 2y will cancel each other out. So in order to get a negative 2y, I need to multiply this entire equation by negative 2. So I'm going to have 3x plus y equals 4. And when I multiply by negative 2, I'm going to end up with negative 8x minus 2y equals negative 16. I line up my x's, line up my y's. 3x minus 8x is negative 5x. And 2y minus 2y, 2y plus a negative 2y cancel each other out. I no longer have any y's to worry about. And 4 minus 16 is negative 12. In order to get that x by itself, I'm going to divide by negative 5. And I end up with x equals negative, well, the negatives cancel out. I'm left with x equals 12 over 5. And in order to figure out what the y value is, I have to plug that x value back into one of the equations and solve for y. I'm not going to do that in this case because this looks like a very ugly number, 12 over 5.